Hello, I'm Eric Macias.
I'm Josh Ormonde.
The specialty concrete we decided to research was pervious concrete.
General specifics of the pervious concrete are usually characterized by a near zero slump, an open grade material consisting of Portland cement, coarse aggregate, and little to no fine aggregate. The need for pervious concrete has long existed, but it wasn't until the 1960s that it started to be used in paving applications. They realized that only having mostly coarse aggregates can lead to higher pore sizes and would allow more water to permeate through the concrete and into the ground. This reduces runoff in developed areas and makes projects more sustainable. With a connected pore size ranging from 0.08 to 0.32 inches, they can vary in appearance and specific advantages. It is mostly due to the size of the coarse aggregate. As seen, the one on the left is a smaller aggregate and can do a better job filtering larger organic material and trash, whereas the right can allow water to permeate at a faster rate. There's no one size fits all, and the use case must be analyzed carefully when designing the concrete mix. Let's talk about some of the advantages of this specialty concrete. There are several reasons a pervious concrete would be used in construction application. Its main advantage in paving applications would be its ability to allow water to permeate through it.
This seems a little counterintuitive because we usually characterize concrete as something that is impermeable, and we usually design it to have the smallest possible pore size. But as we'll see, this one characteristic becomes very useful in paving.
In most pervious concretes, the drainage rate ranges from 2 to 18 gallons per minute per square foot. This may be hard to visualize, so I've included a short video of what that could look like. Pavement in the video is rated to handle the weight of cars and trucks, so it can be used in a variety of paving applications. Not to mention, it's draining at about 1 gallon per minute per square foot, as advertised by Top Mix. This would be considered on the low end, but as you saw, it's impressive nonetheless. Other notable advantages include being a less slippery surface on snowy and rainy conditions, therefore reducing hydroplaning. It also has quite a bit of air inside of it, so it allows for lower pavement temperatures, creating additional lift in aircraft takeoffs. It also reduces glare on wet surfaces, particularly at night. Pervious concrete also has good sound deadening qualities, and that can reduce the interaction noise between a tire and the pavement. One of the bigger advantages being that they can reduce the size of storm sewers and in some cases even eliminating them. And lastly, they allow for air and water to reach tree roots and plant roots inside of landscapes along crosswalks and roadsides. So plenty of positives.
As well as the many advantages to pervious concrete that Eric mentioned, there are many disadvantages and limitations. One such disadvantage is its high cost. Since it has very little, if any, fine aggregate, more cement must be used. The low water to cement ratio that it is mixed with makes it even more expensive than it just having almost no fine aggregates. Another aspect that adds to the cost of the concrete is the need for the coarse aggregates to have a narrow gradation. This either increases the cost of the aggregates or makes it so the aggregates must be separated on site. To add to the cost, the concrete is usually poured thicker than others, which means more concrete will be used. Strength is another disadvantage of pervious concrete. It is not as strong as other types of concrete, which makes it difficult to use at times while remaining cost effective. Its strength is also problematic because it depends on porosity, which means measuring the true compressive strength is hard due to the fact that it can vary so much with the way it is placed. In order to have the concrete strength go up, the porosity must go down. The disadvantage of placement has to do with the difficulty of handling it since its workability is so bad. Its low water to cement ratio makes the mix very stiff, which allows the pores to form, but also increases the difficulty of placing the concrete. To make matters worse, the concrete has to be placed in a specific way, or else the characteristics of the concrete may change drastically. It also takes a longer time to cure than other concretes, which may be inconvenient in some settings. Fly ash is sometimes used to increase the workability of the concrete. Repairing the concrete can be quite difficult since most road repair substances that are used also act as sealants, which conflicts with the purpose of using pervious concrete in the first place. When used on high-speed roads, large aggregates tend to break off, which may then be launched into people's windshields, creating a safety hazard and could result in lawsuits. It is also quite possible the pores of the concrete may become clogged by leaves or soot, and it would then need to be cleaned with a street sweeper or a power washer. Pervious concrete has a large amount of applications. One such application is its use for roads that are not heavily trafficked. Not only does it allow for drainage and reduce road noise, but it also increases skid resistance and reduces the glare from the road when it rains. This is especially useful in areas where nighttime traffic is common alongside rain. Another application is liquid-solid separation operations, such as agricultural dewatering, sewage treatment plant sludge beds, and floors for zoos and barns. It's used as greenhouse floors to allow excess water that would normally build up to drain, used for swimming pool decks for the same reason as greenhouse floors, and tennis courts, since tennis balls will not bounce the same if they become wet. Some other applications include structural walls that need to be lightweight and or have better thermal insulation, bridge embankments, rigid drainage layers under exterior mall areas, wall linings for drilled water wells, beach structures and seawalls, artificial reefs, and parking lots. If you have any questions for us, please feel free to contact us via email or Canvas or talk with us during our next class meeting.